After completing that first laboratory, you must be thinking there's got to be a better way. Coding in machine language is a real pain. Well, you're right. There is a better way. If you remember back to the first reading we did about the history of software, you'll remember that the second step past machine language was called assembly language. And that's what we'll look at now. I'm going to start with the same example that we did before, the sequence example, loaded into memory. We're going to run fast here, and just to remind you what that does, we'll do a quick run. It adds what's in location 4 to the constant 5 and puts the result in the accumulator right there. Now, I'm going to fire up what's called the assemble window. The assemble window is going to do that tedious translation for us from these binary opcodes and addresses into assembly language. To let it do that, I'm going to load exactly what's in memory into this right side window. It's just a copy. And then I'm going to use the disassemble button and look at that on the left-hand side. It's translated all of those binary codes into something that's a lot easier for us to read. We can see that the location 4, where we put that number, is 40 in decimal. Sure enough, 40 in decimal right here. And then the output has been stored in location 5, 45. Now what I'm going to do is make a small change to this program, and instead of adding decimal 40, I'm going to add decimal 50. To go from left to right, I hit the assemble button, and you'll see I've changed that location in memory. I can now save it back to memory, and it's changed here. If I reset and run again, we should get a different result in the accumulator. Right here it is. And if I wanted to see it in decimal, I could see that I've now added 5 to 50 and gotten 55. Alright, that was cool. Let's see if we might be able to make a slightly more difficult change. First I'm going to change this back to 40 before I forget it. And then what I'm going to do is I'm going to try and add an instruction here that will output our result, as opposed to just leaving it in the accumulator. So, after the store instruction, I'm going to insert an output instruction. Now notice it's giving me a list of all the addresses over here, and so I'm going to have to change that address to a 4, and that address to a 5, and that address to a 6, and frankly I don't care about the rest of them, so I'm just going to get rid of them. And now I'm going to assemble the program. You see the extra instruction has been inserted here, everything else has been moved down 1, and so I'll save that to memory, and now run again. That's a weird result. That's not what I expected. What happened? Well, let's take a look at our program. We loaded immediate 5 into the accumulator. We added what was in location 4. Uh-oh! Look what's now in location 4. We added an instruction, so we're actually adding the stop opcode to 5. That's not what I wanted to do. I wanted this number right here. So I'm going to have to change my program. I'm going to add what's in location 5, and I'm going to store it into location 6, so that my result should go down here. Okay, let's assemble that and try again. That looks better in the accumulator, and it looks better in the output. Now, one other trick I could do here, the assembler is actually smart enough to let me call things by names instead of numbers. So instead of saying I'm going to use location 5, I could say I'm going to use location X, and I could let it figure out what that must be down here. Likewise, I could store it in location Y and name that location Y. And if I assemble that, you'll see that it figured out exactly what to do, knowing that location 5 must come after location 4, and location 6 must come after location 5. However, I've now added information here, this human-capable reading X and Y, symbolic reference, that the machine really knows absolutely nothing about. So if I have to take what the machine knows and disassemble it, guess what? All it knows is 5 and 6. We'll see this gets even more important as our programming languages become more and more powerful. What's left in the binary in the computer loses some very significant information to help humans understand what's going on. With that introduction, you should be ready to tackle the second lab in our assembly language series. Good luck!